this is the somatosensory anatomy for conscious awareness. And we have now moved up superiorly to a new section. So, first question, where are we? Well, our landmarks are this structure and this structure. Answer what those are. Okay, we've got our pyramids and our inferior olivary complex. Therefore, what level of the brainstem are we located? We're located in the medulla, indeed. Okay, are we inferior medulla or superior medulla? The wide open fourth ventricle tells us that we are now in the superior regions of the medulla. So now we're going to look at our pathways, and again, you will have to look on your handout. There's no way you're going to be able to see this up here on the board, but it gives me something to point at. So we're now in superior regions of the medulla, and so this tells us we're going to have to find our medial lemniscus, we're going to have to find our anterolateral system, and we're still going to have to find our descending or spinal nucleus and tract of the trigeminal system, and we're going to have to find our ventrotrigeminal thalamic tract. Okay, so let's go ahead and do that on the sections. All right, so starting out with our fast somatosensory information for the body. Oh, and we should erase what's no longer present. We know we have to find our medial lemniscus, but our dorsal column nuclei and our internal arcuate fibers are now all gone. And all that's left is our medial lemniscus. Slow somatosensory from the body, still anterolateral system. Slow somatosensory from the head. We're still going to be looking for that descending nucleus and tract of the trigeminal system, as well as VTT. All right, so where are these things found? Well, here, our medial lemniscus is still a headless homunculus standing on the pyramids. So the upper body would be located more posteriorly, and the feet, fibers carrying fast somatosensory information that originated in the contralateral foot, because remember this is after it's crossed the midline, would be located more ventral or anterior. So that's all the same as we saw before. Medial lemniscus, information is coming from the contralateral body. What about our anterolateral system? It has hardly moved. Same information, same place. Anterolateral system, the information is coming from the contralateral regions of the body. And we also have our descending nucleus and tract of the trigeminal system. Here's the nucleus with the tract found more lateral. So that's descending nucleus and tract of the trigeminal system. And these higher order neurons are still sending their axons across the midline to run in VTT. And they're heading to the ventral posteromedial nucleus of the thalamus. So again, nothing has really changed here. Running across, running in VTT, heading on up to VPM. And looks like I didn't fill in this information here. The spinal nucleus and tract, that information is coming from the ipsilateral side because, of course, these are primary afferents sending their information in, running in the tract, and making the first synapse here in the nucleus, and do primary sensory afferents cross the midline? Pause if you need to. The answer is no. And so this information is coming from the ipsilateral regions of the head. But once we're in VTT, that is after those fibers have crossed. So in VTT, that information is coming from the contralateral portions of the head. So that's all just review. We saw all that on the previous section. Now what I also want to show you here, though, is now we have a full inferior cerebellar peduncle. It's a nice big fat fiber tract. There are lots of things within there. However, the only thing you're going to have to worry about right now is that proprioceptive information from the lower and upper body heading off to the ipsilateral cerebellum. So, all this same information, proprioceptive information on its way to the cerebellum, this pathway stays ipsilateral all the way, and it's going in through this inferior cerebellar peduncle. Okay, and remember, this has nothing to do with conscious awareness of proprioception. This is just getting that proprioceptive information to the cerebellum so that we can have coordinated movements. And you'll learn all about that later in the class. But that's the pathway that it takes. All right, so we're now going to move superiorly to this next section. And of course, our first question is always going to be, where are we? So we have some landmarks here. And one is this batch of nuclei all through here. Pause if you need to. Those are the pontine nuclei. We also have a nice big fiber tract out here laterally. Pause if you need to. Middle cerebellar peduncle. And we have a nice tight fiber tract located posterior here. Pause if you need to. That is the superior cerebellar peduncle. If we have pontine nuclei and the middle and superior cerebellar peduncle, we must be at what level of the brain stem? We must be in the pons. So now we know we're looking at this region, but we need to know, are we in the inferior pons or the superior pons? And pause if you need to. Our landmark for that is going to be the fourth ventricle, which in this section is sort of squished, getting smaller now. And we have separation between the superior and middle cerebellar peduncles. So we are in superior regions of the pons. So now we go to our pathways diagram, to the pons, and go to superior regions, and we see there's some new stuff we're going to need to find for somatosensory information from the head. But for the body, still medial lemniscus for fast somatosensory, still anterolateral system for slow somatosensory. So let's go ahead and find these things. So our medial lemniscus is located right there. And at this point, it's changed its orientation. So remember when we were in the medulla, we had a headless homunculus standing on the pyramid. So the feet were anterior and the shoulders were posterior. Now this homunculus has done some really gnarly splits, right all the way on up to the shoulders, such that the legs go lateral and the shoulders stay medial. So now the feet are located out here, and the head is located here. And remember, that information is still coming from the contralateral body. So the medial lemniscus, there's no change here. The structure has moved its orientation, but that information is still coming from the contralateral body, and it's still fast somatosensory. What about our slow somatosensory information? That's going to be in the anterolateral system. And there's no change here either. Our anterolateral system still is originating in that contralateral dorsal or posterior horn, and that information originated in the contralateral body. So no change. The structure you got to find was the anterolateral system, and that information is slow somatosensory from the contralateral body. Okay, but now we have something new here. We have a new nucleus, which is the principal nucleus of the trigeminal system, and that's going to be handling fast somatosensory information from the head. So let's look at that. We've got our primary afferent out there in the periphery with its cell body. You probably can't see that on there. With its cell body in the trigeminal ganglion, and that axon's going to come in and make its first synapse right here in the principal nucleus of the trigeminal system. So this is the pre-thalamic relay nucleus for fast somatosensory information from the head. And then that higher order neuron is going to send its axon across and ascend, and that's also going to go to the ventroposteromedial nucleus of the thalamus, and that's running in VTT. Now, an important thing, we're now here, VTT, that information, the slow somatosensory information from the head also has to get through this section. And so now VTT has both fast and slow somatosensory information in it. They're both found in VTT. And then this is our principal nucleus. Okay, and you might notice there's one more structure highlighted on this slide, and this is one of our oddball situations in neuroanatomy. So, primary sensory afferents have their cell bodies located in what sort of structure? Pause if you need to. They're supposed to have their cell bodies in a ganglion, and the vast majority of them do. However, for proprioceptive information coming from the head, those primary sensory afferents have their cell bodies in the mesencephalic nucleus of 5. And everybody always asks me, why? Who knows? But they do. So I'll just draw that in here. I'm going to take this one out just so we can see it. That primary afferent is going to send its axon in through the trigeminal nerve, but it doesn't have its cell body in the ganglion. That process goes all the way in, and it has its cell body located right here in the mesencephalic nucleus of 5. So we'll go ahead and call that 5C so that I can put it back on the board, but this is still part of fast somatosensory information. Then that axon is going to come and make a synapse right here in the principal nucleus, just like all the rest of fast somatosensory information. So once it's going to make that same synapse here in the principal nucleus, and then that higher order neuron will cross the midline and ascend to VPM, going through the ventrotrigeminothalamic tract. Okay, so let's get this on the board. So now we're talking about our fast somatosensory information for the head. And that first structure there, 5A, is going to be the principal nucleus of the trigeminal system. And then, so if we're talking about the principal nucleus, is this information coming from the ipsilateral head or the contralateral head? Pause if you need to. It's coming from the ipsilateral head. That information originates in the ipsilateral head and it makes its first synapse right there. So this is going to be ipsilateral. Then those axons cross the midline and ascend in VTT. So we're also going to have VTT. And that, of course, it's just crossed the midline, so that information originates in the contralateral head. And then we've got our oddball, which is 5C. I'll just stick it up here because there's no room down there. The mesencephalic nucleus of the trigeminal system. And this is our weird ball. These are primary afferent cell bodies. But the neurons located there also send their information for that first synapse to the principal nucleus of 5, which then sends its information through the contralateral VTT. All right. So I think we've covered everything on this. So what you should do next is, using your Pathways handout and the posted information in online, review all of the structures from section 6-14 and 6-21 that we just covered. And once you've drawn them in yourself on clean copies of these sections and reviewed all of the questions for each of the structures, then come back and watch the last of the lecture.